Hi folks, this is Bruce back with Groxio, and we're working through our Tetris game. We've made a lot of progress to the point where we can move pieces back and forth, we can rotate them, and as I reload you can see that it creates a random brick. And obviously this won't usually happen when we reload, but I want you to show you that the capability works. So the next step is to allow these pieces to move down. But to do this, I need to basically make a different model for the bottom of the screen. And there are a couple of things that I want to talk about, a couple of design considerations. So the first thing that's interesting is one of the things that's nice about Phoenix LiveView is that these elements are only going to cause anything to be downloaded if those elements change. So there's a couple of strategies that we could use. One, we could try to render all of the points at once in for the tetromino and the bottom. And I don't want to use that approach. And the reason is that if we want to send down only the updates, we only want to send down the few number of boxes in the tetromino as it drops. And then only when it hits the bottom do we want to send all the boxes down in the combined bottom section of our game. So what we're going to do is we're going to make it easy to render separately both the bottom and the tetromino. And so the bottom is going to need boxes that are shaped pretty much like the ones in the tetromino. So the other thing that I want to talk about is that in the bottom, one of the things that we want to be able to tell is when you're moving, we want to be able to handle the collision. And this is what I mean. So let's say that the white on the right is a collection of boxes. Right now we can move right through them. And eventually we're going to have to limit that. And to detect the collisions, we're going to need to know if any of the boxes are overlapping. And so the easiest way to do that, since there is also color involved, is to basically build a map and just look through only the XY portion in a map. So essentially our bottom is going to be stored as a key value pair in a map where the key is the XY coordinate and the value is the XY color three tuple. And we're going to use the three tuples. We could basically do the map.values to get all the three tuples to render the whole bottom at once. And then we're going to use the key in order to quickly look things up for when we collide. So now I'm kind of feeling happy that we decided to do this project in a Poncho project rather than a Git dependency, because it's all the same code base and we'll be able to look around here. So let's go ahead and tidy up the left-hand side. Let's shut down everything but the live view. We'll leave that one open just in case we need to refer to it. And we'll create a new model. So I'm still saving the Tetris for a clean, beautiful API that has all the bells and whistles for it. That'll make for very lightweight use in the user interface. So now I think I'm just going to build something called bottom. And that's going to be, so this is the Tetris project. That's going to be an Elixir file. And it's a module. It's going to start with Tetris on the top. And then I'm going to have bottom 2. And this is going to have a couple of attributes. The main, let's see, maybe the best thing to do is to represent this as a map. And maybe this should be a map that doesn't have anything else related to it. I think that's what I'm going to do for now. And the reason is that it's essentially like points. Points serve as the model for a tetromino. But I think that for this one, we'll just take a map and we'll merge in. We'll allow us to build the bottom slowly. So the first thing that we need to be able to do is when something collides with the bottom, we need to merge. So this is going to take, remember, so this is going to take two attributes. And one of them is a tetromino, and that's points. And the other one is the bottom itself, which is a map. Remember, we want to let these match as much as we can. We also want to let this be the first argument. So I'm going to move that over to here, basically, so we can pipe through the bottom as we need to. Okay, and the other thing that we're going to need is to detect collisions. I sadly need to check my spelling. I'm all kinds of dyslexic. Collision, that looks correct. So I'm going to drop back over here. So if it collides, this has a question mark. That's an Elixir convention. That means we're going to return a true or a false. And we're going to take a bottom. And then we're going to take an X, Y, color that we're going to ignore. And we're going to basically check this one against a collision with just the X and Y. And this is a point. Or actually, I don't need to label that, do I? That's pretty explicit. So we're going to check a collision with just the X and Y. We'll drop that point off, and then we'll have another couple of versions of this. And so this, we're actually using the XY for pattern matching here. Okay, and so one of the things about Elixir's checking of true and false is that I can use, for many of the APIs, I can use truthy and falsy. So falsy is a nil or a false, and everything else evaluates to true. So I think that what I'm going to do is effectively create my bottom. I'm going to say my bottom, and I'm going to do a map.get of that bottom. And so I'm going to say it's going to collide if there's a key, if there's an XY key. And since that's going to return whatever that XY key is, probably a better way to do this is the first negation is going to turn, if this is a nil, it'll turn it into a false, and it'll turn it into a true. And so the bang bang basically is going to translate a falsy value or into a false and a truthy value into a true, which is what we want. I think it makes for a cleaner API. And then we're also going to have a collides with the bottom and then points when is list points. And this is just going to be an enum any, and then we're going to go through all the, let's say, bottom, and then get the map that values. So now I'm just working with the three tuples. I'm just working with the no, I don't need just the values, do I? I need to basically say points, and then I'm going to pipe that to enum any, and then I'm going to say I'm going to take a function, and then I'm going to basically well, I've got the function. It's right up here, isn't it? So now I can say Does it collide? And I can just pass that whole function, can I? You know, and this is looking like I don't really need to pipe this at all. So I'll do any of those points collide? Yeah, that's what I'm looking for. It just, how's the one line, a one line version? No, I think that's going to be a little bit too fat. So yeah, there we go. So that's a lot of thrashing as I'm thinking about this, but that's okay. It's good for you to see me kind of wondering and wandering along the way. And so let's think about what a merge would be. It's basically, so I could basically do reduce in a bunch of map.puts, but that's not really thinking functionally. The best way to do this is to take this whole thing and basically I can use an enum into, and the way that looks is this. So I want to eventually generate a list of tuples like this of key value, key value, and basically I'm going to say enum.into my map, and then basically kind of this will merge whatever I've got into my map. And I'm not worried about the order of these things because basically there's no intersection, because I'm going to check collisions before I merge them in. So let's basically turn this into the shape that we need. So we have our points, and we know that those points are basically I think I might be able, yeah. Let's go ahead and do this with an enum into. I think that this is the way to do it. And the map is the bottom. And so this is going to take my function, and this is going to take X, Y, and color. And then we're going to do something with that. So we need the key. This is going to be key value. And the value is going to be X, Y. Just to keep this tight, I'm going to call that C for color. X, Y, and C. And this would be X and Y. And then we're going to merge that into the bottom. And I like that pretty well. I think the intention is pretty clear that we're going to merge all these together. These are all together. They look like they work pretty well. Let's see if we can play around with them in the console. So, oh no, we can go into CD. We're going into Tetris. Yeah. So, and then I can say IEX start the mix, which essentially starts a project. So there's an undefined function collides one, and that's pretty straightforward. What we really want to do is we want to say, does the bottom, the collision is with the and then the point, which is M1. So basically, this means we're working, this first and means we're working with a function, and this is the first attribute of the function. So this is a shorthand notation that's equivalent to fn x, plug in x in right there, but I think I'm going to work with a shorthand. This doesn't bother me like it does some people. It basically helps me condense what I'm thinking about. It especially helps when I'm trying to take an existing function and just dropping the values in along the way. So let's see if this much works. Okay, so I'm going to import so I'm doing an import because basically I'm not going to be working with any other classes. I'm not worried about any collisions. And I'm going to shut this console down as soon as we're done here. And maybe we'll write a quick test, maybe we won't. But basically what I want to do is I want to say one bottom. Maybe there's a 1 point in here, and that is 1, 1. And maybe that maps onto 1, 1, blue. Okay, so now I have a bottom. So I could say collides with the bottom, and then I can give it a point. And that doesn't. That's great. So that still collides, and that collides. And what about a list of points? So what if I take this one and one that does collide? Okay, up. Yep, I tried to make that a tuple. It's really not. So that collides, and that doesn't collide, which is exactly what we're looking for. So, so our collisions work. Now, how about the merge? So that doesn't merge. Maybe we can do a merge with this. Okay, so what did we get? We got a 1, 2 red and a 1, 3 red. And that's exactly what we merged in. And so our keys are 1, 1 and 1, 2, and that's exactly what we want. So the bottom is working. We could write some quick tests if we want. Maybe we should go ahead and do that. These are going to be really quick. So I'm going to create a new file. I'm going to say bottom test.exs. This is a script, not a full file. And let's go ahead and copy one of the existing tests. That usually works the best. I'm going to delete all of these pieces, and I'm going to import Tetris.bottom, and I'm going to alias. Do I need to alias the points? No, I think I'm good. I think that we're going to use test various collisions, right? And so now I can use some of the code right here. So I have a bottom here, and I check a bunch of collides. Yeah, so I check a bunch of collides. So let's grab all this code, and we'll figure out what to do with it once we're in the console. So, so these IEXs, I'm not going to worry about those. So now I have a bottom, and this is going to be, okay, so now I'm to the point where I could start taking some of these and doing my multi-cursor trick. Let's convert all these at once. Assert, and let's make this collides. And basically, we're going to have to wrap these into parentheses, just to be clear. Okay, I think I like that. And I really want to work on this one that worked. Collides. And so rather than the equal false here, I could change that to refute. And I could take that off. I could take that off. And I could change this one into refute. And I can drop that as well. Okay, I like that better. So we're asserting collides. Yep. That returns a true or false. That's good. And then I'm going to refute this one. Collides of this. And I think that looks great. Let's see if this one, I'm going to go ahead and drop out of here. Okay, cannot define a brick test. Okay, so we didn't change the name of this. So this is we're testing out the bottom. Okay, that test worked okay for me. And so now I'll probably just want to do one more test. This is basically another Tetris one, my proof of concept before. So I test a few of the high level concepts before I live code an exercise, just to make sure I have the rough structure right. So I'm going to do a test, and then we're going to do various merges. So that's a little bit sloppy, but I just want you to get the idea of how our tests are looking, and I also want to know if things are about to blow up on me as we're doing some of the refactors through these live coding exercises. So it might seem to you that that actually writing these tests will slow me down in the terms of these live coding exercises, but it actually speeds me up because I'm actually going to have more confidence in some of the pieces along the way. So I'm going to say, so my actual is this, and my expected is this. Let's do this a little better. I think that's fine. And I'm going to assert like that. And I think that that's probably a pretty good piece of a pretty good test. Just a basic, simple one, just to test the rough proof of concept. Okay, so now we have a merge, and now we have a collide. So probably, is there anything else that we need to do? I think that that's probably it. We probably have enough to get to go by in terms of our actual Tetris API. So I think that this is a good place to take stock. And one of the things that we'll do is tighten up the usage model for our LiveView Tetris game. So let's wrap things up right here and then move on to the next one.